Hello, math nerds. It's the crazy math nerd, Kitty Morgan here, with another installment of some fun calculus goodies. And today's big question is, what is f double prime of x? What is that? And so that's the question we're going to answer today. So before we go there, let's go back to what we talked about in the first video and talk about how does f prime tell us about the function. So f prime is an indication of how f of x changes. For example, if f increases, then f prime is positive. If f decreases, then f prime is negative. And so I've written this in a vertical, well, it's linear, but it's a vertical fashion because this is how I think about the relationship of f prime, and double prime. I think about them vertically because each one of these is how the one above it is changing. So f double prime of x is how f prime of x changes. Okay? So wait a minute, what does that mean? Well, we call f prime of x the slope of the tangent line, of f. Right? Yeah. So really, f double prime is how the slopes of the tangent lines of f of x are changing, or how they change. And so a lot of times you'll hear me say f double prime is how the slopes change. I'll kind of take that little part out just because it's for brevity. So f prime is how f changes, and f double prime is how the slopes change. Okay, so let's take a look about how that would look graphically. So here in your notes, I have some little sketches of some different things that graphs can do and how they curve, and I've drawn some tangent lines to this first one. And let me change my pen color to red. Here we go. So how are these slopes changing? Well, this is a positive slope, and notice that this positive slope is getting larger. So f prime of x, the slopes, are increasing. Okay? So f prime of x is increasing. And what does that mean? That means its derivative, f double prime of x, is greater than 0 or positive. Remember how we talked about in the last section that greater than 0 means positive? Okay? So I'm going to say this statement again. When f prime is increasing, its derivative is positive. Okay? Same thing when we said when f was increasing, its derivative f prime was increasing. That relationship will continue on throughout the derivatives. So on this next one, I'm going to have to really think about this, and I'm going to change my pen color to green. So I'm going to draw some little tangent lines here. And when the slopes are negative, I have to really think about this, so think with me if you will. So these tangent lines are negative, and they're getting steeper, but with a negative value. So if these are getting steeper, but with a negative value, then we say that f prime of x is decreasing. That f prime of x is decreasing because the value of the slopes is getting smaller. Even though I know that's a steeper slope because it's negative, the value of the slope is getting smaller. So if f prime of x, that's a crazy little x I have right there. Let me erase that for just a minute. Ooh, excuse me. Got some little things on there I didn't want. If f prime there of x is decreasing, then f double prime of x is less than 0 or is negative. Okay? All right, let's get us another color. Let's see, we've done red and green. We'll just do a little black here. So here we go. We're going to draw. Oh, no, I'm not going to draw those by hand. No, sirree, I'm not, because I don't do that very well. Oh, and I got to change the pen color on that. Here we go, drawing tangent lines. Now again, my tangent lines are negative. Do you see that? The slopes are negative. But notice that, well, That was a little crazy. But notice that as we go on, this steepness decreases. But when you have a big negative and it gets less negative, then really the value is increasing. And I'm going to come over here real fast and talk to you about it on a number line because this is confusing a little bit to me. So I have to think about it. So this is big negative. That's how I think about that. Like negative 1,000's over here, right? And so it's not really a big number, but it's a big number that has a negative value. So as you go into 0, your numbers actually get bigger, right? As you go from left to right on the number line, you get bigger. So that's kind of how you have to think about it when you think about negative slopes. I have to slow down and go, what does that really mean about the value? So this is a negative value that's actually getting smaller going to 0, which means f prime is actually increasing. The slope's values are increasing. And if f prime increases, then f double prime is positive. Okay, so sorry I have to go a little slow when it's negative values, but I have to get that number line in my head. Let's go to this last example. We're going to get a little pink fun thing here. I'm going to draw some tangent lines, and we have some positive slopes. There we go. All right, so notice that your slopes are positive and they are getting smaller as you go. So that means that the slope values are decreasing. Slope values are decreasing. And when they do that, that means f double prime is negative. Well, because of how the slopes act, it makes those little graphs curve a certain way. So that's what we want to talk about now. And I don't know if we've talked about this particular vocabulary, so just be patient with me. So I've got my pen. Let me get in some blue here because I want it to be the color of that. There we go. So notice that in this graph, it's kind of doing a cup up. We call this concave up. That's what it's called. If it'll hold water, or if it looks like your hand, either side of your hand when you cup it up, it's called concave up. This is called concave down. So if you hold your hand concave down, like making a upside down U, then if your graph is on either side of your hand, then that's called concave down. So guess what this is called? That's right, concave up. And this guy is concave down. Okay, now let's look at the relationship of the second derivative and the concavity that we've talked about the graphs. Well, that's a concave up there, and that's a concave up there. Do you notice anything about the second derivative? Ooh, I think they're positive. Okay, and look at when the slopes decrease, that makes a concave down, and both of those, concave down, both of those, your second derivative is negative because your slopes are decreasing. So when your slopes increase, you make a concave up. So both cases, when your slopes are increasing this way or either increasing this way, right, they make a concave up. If your first derivative the slopes are decreasing, then that makes a concave down or a concave down. So if you hold your hand up like a U, then you're making both sides. There's the right side of that concave up on your hand, and that's your left side of it. And then if you turn that hand upside down to make an upside down U, you've got the right hand side of the hand and the left hand side of the hand. So concave up looks like a U, and a concave down, turn your hand upside down, you've got concave down. Okay, so let's talk about that. We just learned some new vocabulary. So what does the second derivative tell me about the original function? Well, if the second derivative is positive, and you know that's what that means, second derivative is positive, then let's see, positive, positive, then f of x is concave up, like a cup. I'm going to write that right here, like a cup, like a cup. Because the slopes are increasing, that makes it curve up, okay? And so if you think about it, here's your concave up, and then like a cup. Yay, isn't that fun? All right, so if your second derivative is negative, that means that your slopes are decreasing. And if your slopes are decreasing, that means that your original function is concave down. And guess what? You're not going to believe this. Like a frown. I know. It's so sad, isn't it? And so if you draw concave down, then you put your little eyes and your nose there, you've got your little frown. All right. I know I'm always rhyming stuff. So concave up, like a cup. Concave down, like a frown. And for me, this is kind of goes together, the positive and the up and the negative and the down. And if you think about how your slopes are changing, that also helps that make a really good sense there. So what happens if the second derivative is 0? Well, let's take a look. I need another screen for this. So if you have your second derivative 0, then I'm going to do this in blue. Then you have a possible, hold on just a minute, so sorry. I hate these little things that come up. Then f of x has a possible point of inflection. Possible point of inflection. And a point of inflection is where your concavity changes. So it doesn't mean you have one, it means you have a possible one, okay? Point of inflection. And point of inflection, I can talk faster than I can write, huh? Point of inflection is the point where the concavity changes, where concavity, sorry about that, changes. Okay. So in this case of this fun little swoop, I love this little guy. It's like an exaggerated x cubed. Notice that this part is concave down, but at some point it starts looking like your hand that's cupped up that would hold water, right? And that's usually, I'll say this, it's usually between your maxes and mins, like somewhere right in there. We kind of halfway in between. So that is your point of inflection. And so that's where your concavity changes. The reason we say we have a possible point of inflection is because if you take the graph x to the 4th and you take the derivative twice, and you take that second derivative of 12x squared and you set that equal to 0, then you would get x equals 0, right? And so if you just said, hey, everywhere the second derivative of 0 means there's a point of inflection. But notice on x to the 4th, which looks very similar to x squared, but it's just skinnier. Right? This looks like x squared, but it's just skinny. Then right here, is there a point of concavity change? There is not, because this is concave up the whole time. So you can get fake information if you're not careful. So when you find the second derivative equal to 0, in order to find out if it is an inflection point, you have to check to see if it changes signs around it or changes concavity around it. Okay? All right. Well, that's a lot of vocabulary, isn't it? So just to recap for just a minute, let me go back on this one. So we've got, if the second derivative is positive, concave up. Second derivative is negative, concave down. If the second derivative is 0, possible point of inflection, and all that means is where the concavity changes. Because think about it, if you are negative and then you switch to positive, wouldn't your concavity change, right? So if you're less than 0 and greater than 0, then that 0 point is where you would change. But just because you have a 0 point, like in this case here, doesn't necessarily mean that you do have a point of inflection. So you have to check for that change in sign for the second derivative. Well, hope this has been helpful. Thanks so much, and we'll talk at you soon. Bye-bye.